Wildcats. Today we're at journal page 52, applying the zero product property to solve equations. Okay, let's take a look at example 1. Find the solutions of the equation. So to do this, you set each of them equal to 0. So you add 19 to both sides. X equals 19. Add 28 to both sides. X equals 28. So the solutions are x equals 19 and 28. Go ahead and finish up example 1. All right, let's take a look at example 2. Find the solutions of the equation. So you said x plus 9 equal to 0, x minus 15 equal to 0. So you subtract 9 from both sides, x equals negative 9. Add 15 to both sides, x equals 15. So x equals negative 9 and x equals 15. All right, let's take a look at the next example. All right, so here, find the zeros of the function. So you're going to set negative 0.1 parentheses x minus 1.4 equal to 0, and x minus 3.3 equal to 0. Here, you're going to divide negative 0.1 by both sides. That's 1. You get x minus 1.4 equal to 0. And then you add 1.4 to both sides. So x equals 1.4. All right, here you just have to add 3.3 to both sides. And x equals 3.3. All right, so x equals 1.4 and 3.3. Take a look at the next example. So find the zeros of the function. So you set x equal to 0. You're done. Set x plus 21 equal to 0. Subtract 21 from both sides. X equals negative 21. So the zeros are x equals 0 and x equals negative 21. Let's take a look at the next example. All right, so here you're going to set 1/2 parentheses x minus 1/2 equal to 0. Divide both sides by 1/2. Anything divided by itself is 1, so that's 1. So you get x minus 1/2 equal to 0. All you have to do is add 1/2 to both sides. X equals 1/2. So the 0 is x equals 1 divided by 2. All right, let's take a look at the next example. All right, solve the equation using the distributive property and the zero product property. So we need to distribute here. Negative 2x times x is negative 2x squared. Negative 2x times 17 is minus 34x. Negative 13 times x is minus 13x. And then I'm not quite sure negative 13 times 17 off the top of my head, so we're going to use a calculator. So negative 13 times 17 is negative 221 equal to 0. So we're going to combine the x's. So that's negative 2x squared minus 47x minus 221 equal to 0. Okay, now this looks like it's factorable, but it could be difficult. So what you can do is you can go to on, new document, no, and add graph. Okay, so we're going to do negative 2x squared minus 47x minus 221. Now, I don't see, there should be 2 zeros, so I'm going to go to Menu, Window Zoom, Zoom out. I've clicked once, press Escape. I can delete the equation. Now, Menu, Analyze Graph, 0, click, drag, Menu, Analyze Graph, 0, click, drag. So my zeros are negative 17 and negative 6.5. All right, let's take a look at the next example. All right, solve the equation using the distributive property and the zero product property. So 9 times x is 9x. 9 times negative 4 is minus 36. Negative x times x is minus x squared. Negative x times negative 4 is a positive 4x equal to 0. Now I'm going to reorder this as negative x squared plus 9x plus 4x minus 36 equal to 0. So here I have negative x squared. I'm going to combine the x's, so that's 9 and 4 is plus 13x minus 36 equal to 0. Now, to make this problem easier, I'm going to divide everything by negative 1 because I want the first term to be positive. So that becomes x squared minus 13x plus 36 equal to 0. Now to factor this, 2 parentheses equal to 0, x and x. Okay, now we need to figure out what numbers multiply to give you 36 combined to be negative 13. Now, in order to get a positive number here and negative number here, both numbers have to be negative. So negative 1 times negative 36 is positive 36. Negative 1 minus 36 is negative 37. That doesn't work. Let's try negative 2. Negative 2 times negative 18 is positive 36. Negative 2 minus 18 is negative 20. That doesn't work, but we're getting closer to negative 13. Okay, so now negative 3 times... Now to figure out that number, what I would do is go to calculator, on, new document, no, and I'm going to do 36 divided by 3. So 12. Okay, so negative 3 times a negative 12 is a positive 36. Negative 3 minus 12 is a negative 15. That didn't work, but we're getting close. Let's try negative 4 times negative 9 is a positive 36. Negative 4 minus 9 is negative 13. So our factors are x minus 4, x minus 9. Set them equal to 0. X minus 4 equal to 0. X minus 9 equal to 0. Add 4 to both sides. X equals 4. Add 9 to both sides. X equals 9. Okay, so our solutions are x equals 4 and x equals 9. Now to check your work, I'm going to graph the original problem without the equal 0. So on, new document, no, add graph, 9 parentheses x minus 4 minus x times parentheses x minus 4. And then I'm going to delete the equation. Menu, analyze graph, 0, click. That's correct. Menu, analyze graph, 0. So I've checked my answers are correct, 4 and 9. All right, let's take a look at the next example. All right, so technically that's a negative 1. So that becomes negative x minus 9 plus x squared plus 9x equal to 0. All right, that's technically a 1. So I have x squared. I'm going to combine the x's. So negative 1 and 9 is a plus 8x minus 9 equal to 0. Factor 2 parentheses equal to 0. X and x is x squared. Now, when you figure out what numbers multiply to give you negative 9 combined to be 8, since the middle number is positive, the bigger number is positive. So negative 1 times 9 is negative 9. Negative 1 plus 9 equals 8. So our factors are x minus 1, x plus 9. Set them equal to 0, x minus 1 equal to 0, x plus 9 equal to 0. Add 1 to both sides, x equals 1. Subtract 9 from both sides, x equals negative 9. So the solutions are negative 9 and 1. All right, and we're going to go ahead and graph this to check. So new document, no, add graph, negative parentheses x plus 9 plus x times parentheses x plus 9. And then I'm going to delete the equation, get that out of the way. Menu, analyze graph, 0, click, drag. Menu, analyze graph, 0, click, drag. And that verifies our answers are correct. All right, let's take a look at the next example. All right, the height of a football after it has been kicked from the top of the hill can be modeled by the equation h equals 2 parentheses 8 minus 4t parentheses 2t plus 5, where h is the height of the football in feet, in time in seconds. How long is a football in the air? So we're going to graph this. So on, new document, no, add graph, 2 parentheses 8 minus, you have to use x, so minus 4x, parentheses, parentheses, 2x plus 5. All right, now we're going to go to menu, window zoom, zoom fit. Let's delete the equation. Now we're looking at this section right here. Now when we're talking about time and height, those can't be negative. So we're going to go to menu, window zoom, window settings. We're going to change that to 0 and the y-min to 0 and press OK. All right, so now, I don't know what that is. All right, and then now we're going to find when it hits the ground. So menu, analyze graph, 0. So the football was in the air for 2 seconds. And again, go away screen. So the football is in the air for 2 seconds. All right, let's take a look at the next example. All right, the depth of a scuba diver can be modeled by the equation d equals 0.5t, parentheses 5.5t minus 44.25, where d is the depth in meters of the diver and t is the time it minutes. Find the time it takes the diver to reach the surface. All right, so again, we're going to graph that. So on, new document, no, add graph. And so that's 0.5 parentheses, oh, no, I'm sorry, x, we're using x instead of t, 5.5x minus 44.25. Now, again, an error came because you have an x and a parentheses. You need to put a time symbol right here. All right, so we're going to go to menu, window zoom, zoom fit. Now, this graph's going to be okay. We don't need to, but here's a diver. He's underwater, underwater, and then here's where he hits the surface. So we're going to go to menu, analyze graph, 0, click, drag, and we can see that rounded to the nearest minute would be 8 minutes. Okay, so the time it takes for the diver to reach the surface is about 8 minutes. All right, go ahead and finish up this example, start working on an assignment, and have a wonderful Wildcat day.